Are you aware of the fundamental physical effect not considered in the classical lamination theory? CLT. Let's take a moment and see why it matters. In the free case, only NX acts on the layer. No other force arises. But what happens in the laminated structure? A laminated composite structure is formed by stacking layers with different material properties and bonding them together. All classical approaches, including the Classical Lamination Theory, CLT, assume perfect bonding between the layers. Now, we apply a total NX load to the laminated structure. The total load is distributed among the layers in certain proportions. Let us denote the load acting in the x direction on the layer I as NXI. The critical question is this: is there an additional force due to perfect bonding? Yes, there is. Here's why. Layers have different elastic properties. Since their Poisson ratios are also different, they tend to contract by different amounts in the y direction. However, due to perfect bonding, the layers restrain each other's deformation and prevent free transverse contraction. Therefore, when the structure is subjected to a total NX load, each layer I experiences not only NXI, but also an additional NYI force arising from interfacial contraction incompatibility. This is the Poisson effect at the structural level. CLT, Classical Lamination Theory, does not account for this Poisson effect at the structural level. A careful examination of the CLT formulations clearly reveals this omission. The same omission is found in classical textbooks, such as those by Jones and Reddy. The Zor model is a new equivalent volume model that accounts for Poisson effects at the structural level. This model has been published in Composite Structures by Elsevier in 2026. For more information about the Zor model and access to the published article, please visit the link shown on this slide.